Hello again, this is Mr. Avant coming to you live from my house to teach you a little math. Today, it is Wednesday already. There's been no school. There's no telling what you guys have been up to. I've only had 3 people look at my video, I think, maybe more. But no response on the Zern except for a couple of people, and no one has marked their work as turned in. So here's the deal. If you want to be caught up with your 4th grade math, if you want to be prepared for 5th grade, then I'm going to keep making the videos and I'm going to keep teaching fractions and decimals. So today we're going to go over Module 5, Lessons 16, 17, and 18. We are going to be adding and subtracting fractions. We're going to get past these baby steps of looking at little fractions that are less than 1. Now we're going to move on up to the big dogs. We're going to be adding and subtracting smaller fractions against larger mixed numbers. So watch the presentation coming up next, and hopefully it'll help you out. See you soon. Bye. Okay, here we are again. Back on the whiteboard. Okay, what we're looking at now, I want to do a brief review. We have some new words to talk about. First is a mixed number. A mixed number is this. It has a whole number and a fraction that is less than a whole. And then we have improper fractions. Why are they improper? Because the numerator is bigger than the denominator, and let's go over what that means. So, a numerator is the number of parts. Let's start talking about number of parts. That goes on top. And the denominator represents 1. That's your bottom number. So 8 parts represents 1 whole for this fraction. So one more time, numerator now is just simply the number of parts. Denominator represents the parts in 1 whole. So let's stop talking about shaded and unshaded. Let's start thinking of our number lines and values. Okay? Now let's break these things apart. First of all, let's look at this mixed number. We said that the denominator represents 1 whole. Therefore, this 1 right here probably represents 8 parts. 8 parts over 8 parts. And then we have 6/8 more. So let's break this down. Let's take a different color here. I'm going to use blue. Alright, so this is going to be kind of like a number bond. I'm going to take this and break it apart. We have 1 whole number plus 6/8. Real simple. Next, let's break this 1 apart. What does that really equal? Well, that equals 8 over 8. Remember? All the parts over all the parts. That's 1 whole number. Now, we can take these two and combine them, and we end up with something called an improper fraction over here. This is going to be a different fraction though. We have 8/8 plus 6/8. Remember, just add the tops when we're adding fractions if the denominator is the same, and it is. So 8 plus 6 is 14 over 8. Okay, now let's look at it on the number line. Where does this end up? So I have a number line up here that starts at 0. Here's 1 whole number, 2 whole numbers, 3 whole numbers. And we're talking about 8, and my number line is already broken up into 8s. Let's get a lay of the land here. Let's talk about where are the 8s. Well, the 8s are every one of these marks here. This is 1/8 right here. This is 2/8, 3/8, and then half of 1 is 4/8. Okay? Now we have an idea of where we should put this one. Where do I plot 1 and 6/8? Well, we can think of of it just being 1, here's one whole number, plus 6/8 more. Let's count that off. So we have one whole number, which is 8/8. What is two whole numbers? Well, that'll be 2 times 8/8. That's 16/8. Okay, and what is 3 whole numbers in 8? Well, that would be 3 times 8/8. That's 24/8. So look at that big improper fraction. All right, now we have a better idea of what's on our number line. Okay, let's find 1 and then 6/8 more. So here's 1, and then let me get my blue. We have 1 and 6/8. One whole number, 1, 2, 3, 4, 5, 6. Here it is right here. That would be considered 1 and 6/8. But let's look at it as the improper fraction 14/8. We can count that off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What did I do wrong? Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I counted wrong. This is 14/8. So our answer checks out. It's either 1 and 6/8, or we could call it 14/8. Now let's look at this improper fraction here, and we want to start thinking about how do we get it back to a mixed number, because we're going to be going back and forth like this. I'm going to use orange, and we're going to do a little number bond work. First of all, let's talk about 18/8. Improper fractions, or any fraction, represents division. This is really saying, what is 18 divided by 8? Or how many sets of 8 can I get out of 18? Well, I know already that the second multiple of 8 is, see, we have 8, 16. The second multiple, or 8 times 2, equals 16. So that sounds like a good one right there. So let's start with 2 whole numbers. Remember, 2 really equals 16/8. And then how many more do I need to get to 18/8? Well, how many more do you get from 16 to 18? Well, there's 17/8 and then 18/8. So that's just 2 more. So this is really 2 and 2/8. Let's look at it on the number line. Okay, so first of all, let's find 16/8. Here it is right here. 16/8 is actually 2 whole numbers. And then I can go 16/8, 17/8, 18/8. There it is right there. There is 18/8, or 2 and 2/8. Okay, this is just the basics of this. We're going to use this information, we're going to use these strategies to help us add and subtract numbers from here. Alright, stay tuned for the next one. Okay, here we are again. We are now going to look at 2 problems from Lesson 16 problem set, and our title today is Adding and Subtracting Fractions Greater than 1. Now, I've made a number line right here, and I'm telling you right here that this is going to be Lesson 16 problem set. This is on page 85, 86. The first one we're going to look at is a subtraction problem. That's 3b, and then the next page, 86, is 6c, which is an addition problem. Now, these fractions that we're using today are going to be multiples or factors with 3. And therefore, we have to make a kind of different number line because we're not using halves and fourths and eighths. But the 6 can work with those, but the thirds and the ninths won't. So this is a special number line just for that. You need to practice making your number lines for fractions. It's very key to understanding how this works. If you can't make a number line or a good model of fractions, you're going to get confused. So let's look at what we have so far. First of all, I started by making thirds, and I have one whole number, two whole numbers, and three whole numbers. So with the thirds, we have 1/3, 2/3, 3/3. That's one whole number. Then two whole numbers is 6/3, and three whole numbers is 9/3. Pay attention to those fractions. Look, 6/3 equals 2 because 6 divided by 3 is 2. 9/3 equals three whole numbers because 9 divided by 3 is 3. Remember, fractions are division. It's so simple to see that now, right? Okay. Next, I did my 6. Now the 6 fall into halfway. I can call that 1.5 right there because you can divide 1 and 2 in half and show that it's 6. But you can't do that with 9s. So only look at the blue lines here. 1/6, 2/6 is 1/3, and then 3/6, 4/6 is 2/3, 5/6, and then 6/6 is also one whole number. 6/6 plus 3 more 6 is 1.5. So we'll call that 1 and 3/6. Alright, and then we have 12/6. Look, 6 divided by 12 is 2. And all the way over here we have 18/6. That's equal to three whole numbers. 18 divided by 6 is 3. You see how that works? Alright, now we need to show 9s. And I did that with the color pink. Now the 9s do not fall on the 6, except for the thirds. So it's a little bit confusing, but here they are. The first 9th is right here. 1/9, then 2/9, and then 3/9 is actually 1/3. 4/9, 5/9, 6/9 is 2/3. So that's the equivalent fraction. And then 7/9, 8/9, and then 9/9 is one whole. Alright, let's go over here. What would two whole numbers be in 9s? Well, that would be 2 times 9 on top. That's 18/9. Make a better 18 there. Okay, 18/9. And then what would three whole numbers be in 9s? Well, that's 3 times 9. That is 27/9. Man, can I multiply. Alright. Let's look at these problems now. We have 12/6, take away 6/6. We can do this right off the bat. We know how to subtract the top. Even though this is an improper fraction, all you have to do is subtract. Okay? Now your instructions on the problem set say, turn this back into a mixed number, if you can. In this case, I don't think we will. But let's look at this a couple of different ways, because that's what Eureka is asking you to do. Do these in different ways to understand it. Well, right off the bat, I can subtract 6/6 minus 12/6, and I think that's the right problem. No, I'm sorry, that's 5/6 in the book. 5/6. Okay. Alright, let's subtract. 5 minus 12, or 12 take away 5, is 7/6. Alright? Can I find that up here? Yes, I can. But this is an improper fraction. Let's go ahead and turn it back into a mixed number. How are we going to do that? Well, in Eureka, they use this little trick where they do this little branch, and they want you to pull the whole number out. How many whole numbers do I have in 7/6? Or what is 7 divided by 6? Or how many sets of 6 are there in 7? Well, there is 6, 6. And then one more 6. And then we can simplify one more time. This is what we call simplifying. 6/6 is also equal to 1. And then I have one more 6 left over. So the answer to 3B would be 1 and 1/6. Get used to doing that. Let's look at it another way. I could have turned this 12/6 into 2. Let me write it over here. There are two whole numbers in 12/6. See, there it is on the number line. Minus 5/6. Okay, we could have looked at it that way. So That's two whole numbers minus 5 6. You can take 5 6 away from 1, and you have 1 6 left over, and then that would be 1 and 1 6 2. So you want to start thinking about these in different ways. Alright, let's go over here to our ninths. This is 6C on page 86. I'm going to use green, and we're going to add the top. That's all we have to do right off the bat. 6 plus 6 is 12 ninths. Okay? Now, let's simplify this answer, 12 ninths. What does that really mean? Well, how many whole numbers are here? How many sets of 9 are there in 12? Well, we can look on our number line. Where is one whole number? Here it is. 9 ninths is one whole number. And then 3 more would give me 12 ninths. 1, 2, 3. I think that's right. 2, 3, 4. Let me see. I think that's right. Okay. 1 ninth, 2 ninths, 3 ninths. Okay, here it is, right here. This would be 12 ninths. Okay, looking at the number line, it's telling me I have one whole number plus 1, 2, 3 more. But let's go over here and simplify it. Let's say we have 9 ninths. How many more do I need to get to 12? I need 3 more. Alright, we can look at it that way too. So to simplify that, let me go ahead and put an arrow over here. That is going to equal one whole number and 3 ninths. Let me separate this. Okay, there's your answer. One whole number plus 3 more. We didn't plot the last one, 3b, so let me do that for you. We said the answer was, if we take 5 6 away from 12 6, or if we're taking 5 6 away from 2, we said we're at 1 and 1 6. Where is that at? Well, here is one whole number, 6 6, plus 1 more is right there. There is 7 6, or we said 1 and 1 6. And for the green one, that was 1 and 3 ninths as well. So I'm going to write 1 and 3 ninths here. Man, my number line is busy. Well, I'm going to go back to the problem set book and show you how to do one problem from lesson 17 and show you how to do another problem from lesson 18. See you in a second. Alright, here we are at the Eureka Math book, Module 5, and if you look at the top, it's lesson 16 problem sets. As you can see, the first page is subtracting stuff, subtracting fractions, and at the bottom you can see it's page 85. Alright, let's pick one of these out and work on it. Okay, in this, at first I was showing you how to do this on a number line, but now we're just going to look at numbers and see if we can figure this out just with numbers and paper. So I'm going to look at D right here. I'm going to zoom in on it a little bit. Zoom, zoom. Focus. Alright, oh, it's just like class, isn't it? Alright, so on this one we have 14 eighths minus 3 eighths. Well, I hate the way Eureka makes little bitty tiny numbers, so I'm going to make that bigger. 14 eighths minus 3 eighths. Okay, on this lesson, denominators are the same. All I got to do is subtract. Start with 14, take away 3. What do I have left over? I have 11. Denominator stays the same. 8 parts for one whole. 11 eighths. Okay, now we ask the question, because we have to get this back to a mixed number. We ask the question, how many sets of 8 are there in 11? How many whole numbers are there in 11? It's just like division. Okay, I can even set up a long division problem. 8 into 11. It goes how many times? It goes 1 time. 1 times 8 is 8. Subtract. I've got 3 left over. What does that mean as a mixed number? This is one way to find out. That means I have one whole number. That is the quotient, is your whole number and a mixed number. And then the remainder is 3 parts out of 8, 1 3/8. Okay, that's one way to look at it. Another way to look at it would be like this. I could take that 11/8 and I can say here's one whole number here, 8/8. How many left over? 3/8. This 8/8 of course equals 1. 1 3/8. It's right there too. Okay? 2 ways to do it without the number line. The number line is just a teaching tool to help you get there. Alright, let's look at F here real quick. 3/10 minus 15/10, or 15/10 take away 3/10. Let's make it bigger. Alright, 3 take away from 15. That gives me, in my world, that would be 12/10. How many sets of 10 are there in 12? Let's make a mixed number. There is one set of 10 in 12/10, and then there are 2 left over. See how easy that is? You need to practice that and get better at it. Now, how do I check my work? I can convert this back. Here's a little trick. 10 times 1, and then add the remainder. 10 times 1 is 10, plus 2. 10 times 1 is 10, plus 2 is 12 back over 10. It checks out. Alright, let's do an addition. We'll pick any one of these. Let's look at D here. D says 7/6 plus 6/10. I'm sorry, 7/10 plus 6/10. Let's write it bigger. Alright, 7 plus 6 is 13 over 10. How many sets of 10 are there in 13? How many whole numbers are there in 13/10? Well, I know if I was dividing 10 into 13, I can only get one set out. 1 times 10 is 10. Subtract, I got 3 left over. I got 3/10 left over. So that's 1 and 3/10. See how that works? Or, I'll go ahead and write it down. Or I could do this. I could take that whole number out of 13/10. 10 out of 10 is the one whole number, plus 3/10. This can be converted into 1. Alright? Very simple. Alright, let's move over to lesson 17 real quick. Here's the template I was talking about on page 89. These are number lines you can use to practice. Alright, here's 17. Okay, now what they're doing is they're going to go ahead and give you a whole number. And you have to decide what is the denominator here. So in the first example, they show you one whole number with 3/4 taken away from it. So below that, they change it into 4/4 minus 3/4 equals 1/4. They also did the number line. See where one whole number is? They take 1/4 away, you get 3/4. Okay? You can do all of that. Let's do it for B. B says 1 and 8/10. 1 take away 8/10. So what is my whole here? Look at the denominator. Our whole is tenths. So that can be written as 10 over 10 minus 8/10. Very easy subtraction. That equals 2/10. On our number line, here's 0, here's 1, or we could call it 10/10. Here's 5/10 in the middle. Okay. Let's see, we need 4 marks in between to create 5. 1, 2, 3, 4. Okay, and then we said 10/10 right here minus 8/10. I would jump 1, 2, 3, 4, 5, 6, 7, 8. I'll land on 2/10. Okay, that's another way of doing it. Alright, that's fairly easy. On the back, for the problem set on page 92, they have larger numbers here. They have 1 3/6 minus 4/6. Let's look at that. We need to break that apart. You can do it many different ways. Let's break this apart. 6 is our denominator, so our whole is 6/6 plus 3/6 minus 4/6. Let's rewrite that again. Let's make that 3 plus 6. We'll turn that into 9/6, the improper fraction, minus 4/6. And what's 4 minus 9? It is 5/6. Very simple, right? Let me do one more. I have 1 6/8. Take away 7/8. Let's rewrite it so it's bigger. Or let's simplify. 1 6/8. Our denominator is 8. So the whole number, that 1, is 8/8. Plus 6/8 more. Minus 7/8. Alright. So I'm going to go ahead and put parentheses around that and turn 6/8 plus 8/8 into 14/8. That's called simplifying. And all we got to do is take away 7/8 now. 7/8 minus 14/8 is 7/8. See how easy that is? Okay, let's move on to lesson 18. I love this practice sheet that they give you for lesson 18 practice sheet. They are now stepping up to 3 fractions in a row here. So let's look at B. We have 3/6 plus 1/6. This, by the way, this is page 97. Page 97. The practice sheets were 96 and 95. It's hard to see that. Okay, here is B. 1B. We got 3/6. Let me make it bigger. Plus 1/6 plus 3/6 equals. Well, 3 plus 1 is 4. So that's 4/6 plus 3/6 equals 7/6. Alright, that's an improper fraction. It has to change. How many whole numbers are in 7/6? Or how many 6/6 are there in 7/6? There's only one. So that is a mixed number of one whole number. Here, I'll write it on the side here. 6/6 plus one more 6. Alright, 6/6 is the one whole number and 1/6 more. Okay? You need to get really good at converting back and forth between improper fractions and mixed numbers. Practice this. Have fun. Enjoy your time off, but I need y'all to do some math too. And I will be posting another video on 19, 20, 21, 22 on lessons on Friday. Okay? Take it easy. Peace.